Welcome everyone, thank you for being here. So today I'll be showing you an experiment to see the impact of several context files to perform the same task. So first of all, let me introduce myself real quickly. I'm Elaine. I'm a senior staff engineer at Sphere in Paris, France. Sphere is an agency that has over 900 developers working with more than 100 clients in software development, such as myself, but also cloud, data, and AI projects. We also do training, a lot of training on software development, cloud, and so on. But most recently, we have added also some trainings in proficiency using AI coding agents. So that's really, really in the heart of our expertise as well. I'm also a GDE, Google Developer Expert for Flutter and Dart. Don't hesitate to connect with me on LinkedIn if you want to connect and talk about this topic or anything else on technology overall. So let's talk about context files. If you were attending some of the previous sessions, I think most of you already know what they are, but just we are all on the same page here. So context files, really high introduction and overview. What are they? So for example, Gemini.md is actually a file. This is coming from the Gemini CLI documentation. So it is a file that is somewhere in a project that is giving instructions, defining a persona, providing coding style guides to make the AI's response more accurate and tailored to the project's needs. We often think about only one file, but actually there can be several Gemini files, there can be several context files in one project. So they can be in the home directory of your computer, but also in the home of your project, but and even in child directories. So for example, if for your specific task your agent has to go very deep in the project directory and that there is a Gemini file there, it will use that file as well if it's relevant to the task. So there can be as many Gemini.md files as you want. We are at Google, talked about Gemini, but I'm also going to be talking about Claude in this talk because the experiment I did was on both Gemini and Claude. And Claude, the Claude context file is ClaudeMD. It is basically the same idea where you have the persistent instructions for a project, the workflow, or the entire organization. And this is coming from their documentation as well. In the same way, you can have multiple Claude files. Some can apply to all of the sessions. Some can apply to the project root. Again, even on the parent directory, in case of mono repos, this is kind of interesting. And the same explanation that I gave earlier for Gemini files on child directories, where the agent can scan for subdirectories and use one specific, more deep in the directory path file. It can use that as well. So basically the same idea and the same strategies of having multiple files all over your project. And why those files? Again, if you attended the previous sessions, I think you already know. We need more rules to have better answers, basically to better use those AI agents. And since the adoption of AI coding tools is getting bigger and bigger, we need those rules. So that's why those context files are born. And the thing is that many different teams adopted many different strategies, and going from having small or very big context files. And lately, in those past few months, I want to say a lot of studies have come up where people have assessed the impact of those context files to the output of the answer. And this one made a big hit a few weeks ago. I don't know if you're aware of this study that was made evaluating agents. I didn't talk about agents, I talked about Gemini.md files, Claude.md files, but agents are basically the same thing, but they are an open standard created by OpenAI. So basically a context file as well. And here in this study, they performed some research to see the impact of those context files in, for repository level, so the context files that are actually in the project. You can take a look at this paper here. Is really interesting, but after that, a lot of people came up also with some posts, and they did some, they were also expressing themselves in that matter. And one of there are a lot of conclusions of that paper, but one of the main conclusions is that a lot of people said that we should stop doing the init command on our projects, because one of the things that we can do as a first step into adopting an AI coding assistant, be it Claude, Gemini, or whatever, is you have a really big project. The very first step that you do is that you do Claude or Gemini and do /init. This will generate, this will scan your project and try to populate this file. And since that study right here, and a lot of people did other studies, and they were talking about their point of views, and saying, okay, you must delete your Claude.md file, MD file, never run Claude init, stop using it for agents MD. So yeah, I was thinking, okay, shouldn't I want to try it. I want to see it if it really has an impact on the projects that I work with. So I'll say, okay, I'm going to try my own experiment on that. So the only thing that I forgot to say right here is that this project was scanning open source projects on GitHub. So they were scanning Python projects, because this is what maybe the technology they were comfortable with. And they were, in the study, they did a lot of things, but they scanned 12 Python projects, and they were relying on unit tests to be successful in order to assess if the context file was good or not for their needs. It's a very, very rough summary of the study, but you should take a look at the paper. And the thing is that, as I said in the introduction, I'm a Flutter GDE, I'm a Flutter Google Developer expert. So oh my God, I have to fix this, sorry. I wanted to try it for the technology that I'm comfortable with, which is Flutter. I wanted to use Gemini. I lost my thing. Laser point, yes. I wanted to use Gemini as well. A lot of those studies don't use Gemini. They are relying, a lot of them are using Claude Code, Codex, or others. And I'm using them vanilla style, no customizations, no skills, no nothing. Only the basic functionalities that you get out of the box. I came up with 6 variants of context files that I'll be presenting after. And then I wanted, in order to evaluate the performance of those context files, I picked one very precise task that I chose from an open source project. I evaluate the task, I'll show you that later. I evaluate that task as a medium task that is would take maybe 1 day, I don't know, to even less, to be made. So I looked on the Git history. So this is a task that was already on the project, so I only cherry picked it. And I even did 2 variants to give the agents the prompt, basically. One very comprehensive, where I was giving a bunch of details of how to perform the task, and one that was minimal, only giving like the minimal specs to perform the task. So for the evaluation, we're going to see the tokens that were used, the completeness of the task, and the number of requests that were made, only for Gemini, because I couldn't figure out how to do for Claude. So let's meet the contenders. As I said, we have 6 context files that we are going to evaluate today. So the very first 2, they are coming from Google. They are coming from the Flutter team. There's something really nice that the Flutter team does, is that they have a page here, the AI rules page, where they actually provide the community, they provide the Flutter developers with rules that they recommend themselves. So they must be really good, right? They are coming directly from the Flutter team. And they even have variants themselves. We have a comprehensive with a lot of the master rule set, less than 10K characters, less than 4K characters, and less than 1K characters. So I picked the 2 extremes, the most comprehensive one and the most compact one. So 2 are coming from Google, 2 are coming from Sphere, 2 are coming from a company. This is a project that I worked on, so I'm picking 2 context files from a project that I worked on, and one from a director from Sphere. It's really nice to see that with the popularity or with the growing adoption of AI, even executives like the director of a company can do projects. So Didier is working on a bunch of side projects, and as it turns out, he has a side project that is written in Flutter. So he has some rules and some context files, so I used him as well. One variant, it's coming from init, of course. We're going to try it out. So init, I just pull out here the definition for the init from Gemini and from Claude. So you can see right here the definitions. Basically, it's running init inside of your project. And the last one, what do you think? What's missing? No context file. So we're going to test this out as well. We're going to see if I don't provide anything at all, what kind of results we can get. So this is the summary. One context file created with /init, one from Google, the comprehensive one, a small one from director of Sphere, one from me, and no context file. You can see the number of lines and the number of characters that those files have. So for example, Google one, 700 lines, the comprehensive one, and the small one, only 23 lines, and the number of characters. And of course, this has an obvious impact, since those context files are going to be given at the start of the session. So by using this one, I'm already giving my agent 30K characters as a context file. So maybe divided by 3 or by 4 to get the tokens. But yes, so there's an obvious impact right here from the very first instruction. But yes, here's a summary of the context files that we're going to be testing today. Next step, choosing the project and the task. So as I said, I wanted to pick an open source project, and it turns out there is one organization called Open Food Facts that has this app called the Smooth app. If you are familiar with the Yuka app, you know, the app that gives you nutritional information about groceries and so on. This is basically the open source version of that. And just so you know, the very first version of Yuka, they were based on database coming from Open Food Facts. And they have, they are written in Flutter. They have, I think, over 2 million users that are using their app. It's a really big app, so I think it's a really good contender for for exploring this this task of testing out context files. And I picked this commit, specifically this commit, so you can see. Some of you can consider it small. I consider it okay. It's a plus 224 on the repository, and no deletions. I could maybe find some other that was doing some deletion. You can see the 12 files that were changed here. So Dart files, so basically code files, and one for the localization files. And here's the description of the commit, adding some kind of type, the model from the package, the Open Food Facts package, and even a little bit of refactoring and adding some localization strings to the project. So I think this was a pretty good choice, and so this is what I went with. So as I said, I went from this commit right here, and I asked an AI agent to say, okay, see those files right here, write me instructions to perform this task that is going to be performed by an AI agent, basically. So this was the prompt that I gave. So scan the files modified in this commit and come up with either a comprehensive or the bare minimum spec file. I said, okay, so create a markdown file that is going to describe how to achieve this task. And I said that this is going to be used by an AI coding agent. So you can see I did it twice. And the text in red was what I added to have the bare minimum version. So I had two versions. The comprehensive one looked like this, which is crazy. This is more text than the actual code that was made on the repository. But I went with it, you know. It was like, okay, you should create this file and so on, modify this file, you should do this, 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 and that, okay. And this was the minimal one. Okay, so you should add a discount type, drop down, do this. So basically 5 tasks and some key constraints. So those were the specs, those specs that came from basically the repo. And this is what the instruction that I gave to the agent. Implement what's described in this file. And that's it. And so I went with it. I went on a lot of sessions, either with Gemini or Claude. And so my 6 context files in parallel. So you can see, so yes, black, blue, green, because I color coded them. So I have all the variants right here. So one session was basically one version of the task that was being made by the 6 context files at once. So yes, so after a lot of sessions, this is all of the branches that I created at the end. So 120 total. This is a lot. Why so many? Because I actually did 5 runs for each configuration. So basically, we have 6 context files, 2 agents, and 2 prompts. So this time this, time this, time this is 120. So at the end, I had 120 versions of the task implementation that I just showed you, which seems kind of crazy, but I think it's so cool that anyone can do stuff like that because we have those AI agents. I think it's amazing. Okay, so I did it. I did 120 versions of the same task implementation. Now, let's evaluate them. So the very first thing that we need to look at, it's really small, but we don't need to look into detail, is that for Gemini, when you quit a session, you get the number of requests, the number of tokens that you have. So I saved that. Basically, I screenshotted every session, put it on the side. For Claude, I used this tool right here, CC usage. So I could see, I don't have the header here, so basically this is saying that the number of tokens that was used. And they were not, this tool, as far as I'm aware, they are not providing the number of requests. So I only assessed the number of tokens that were used. And I screenshotted everything. I screenshotted, I put it on the side, and then I took every screenshot that I have, I put it on Google AI Studio, and I say, okay, I have information on this column and this column. Please write the number of tokens, whatever. So I could extract the data by directly using Google AI Studio, was super easy to do. If you ever need to scan text that is from screenshots or from images, really easy to do. Then I needed to score as well. I needed to see if the task was well implemented or not. So I asked an agent also to give a quality score by comparing each branch with the actual implementation that was validated by the real team. So I said, okay, you should compare all of these branches with the commit from this commit that is properly implemented in the spec. So analyze branch by branch. This was kind of fast as well. And at the end of the day, I had this, which is a bunch of numbers, just so you know the raw data that I had. But this is what we are going to be analyzing a little bit more in detail today. So I forgot to put here on the top. It is we have the results for Gemini, and on the bottom it is for Claude. You see, the only difference is that for Gemini I also have the number of requests. And so we have the average token. Since I had 5 runs, I did the average. I could do some other analysis, but I think doing the average is good enough for this experimentation. So I analyzed assessed the number of tokens, the average, the score that was given by the AI, also the average, the overall average, so basically the average of those two. The number of requests, again, the average. And here, oh yes, before I continue, is there any person who is colorblind here? Colorblind? No colorblind people? It's almost impossible, because I think it's 10% of men are colorblind. Huh? Yeah, it is. But okay, because I did a version where this was, you know, in general, for good, we put green, and for bad, we put red. But then I remember that colorblind people, sometimes it's, for one specific type of color blindness, it's brown for both. So this is why I put blue, and this is why I put like some this information right here. If you were too shy to say that to me, come see me after, because I'm curious to see if this is accessible for colorblind people. Well, so these are the results. Again, this is a lot of numbers, though. This is why I color coded, so we can further look at interesting stuff that is coming out from this. And I invite you to look at things that kind of go together. So the black version, which was the init version, basically the context file that was generated by doing /init. And then the one that, the version of, basically I had no context files at all. If any of you here can see a pattern, I find it actually almost passionating. I think it was so interesting to see that. I don't know if you can see, they are reversed. They are, I had exactly opposite results for the black version, so the /init version. For here on the top, again, this is Gemini and this is Claude. So basically, the Gemini version had a really bad score on the tokens. Oh, I forgot to say as well on my full table here. Tokens, we are trying to consume to make a lesser consummation. So the lesser the number here, the better. Score, we are trying to have the highest score. The requests, we're trying to have the lowest requests number. So that's how I color coded them. Here on the first version of the prompt, the /init version had one of the lowest performances, but for Claude, it was actually the best. And for all the other metrics that I'm measuring, it was exactly the opposite. Yes?
Maybe I missed, what the models do you pick for?
Yes, as I said in the beginning, I was not doing any kind of configuration, so it was the automatic, Claude was figuring it out by itself. So I think I have a screenshot where you can see. So for example, it was figuring out by itself, so Opus and Haiku. And Gemini the same, it was Gemini 3 automatic. But sometimes it figured out by itself that maybe it should do some 3 Flash or 2.5 Pro. Everything was automatic, basically. I could have put it, yes, it matters, I know. It matters, but mostly, Claude was mostly using Opus, Gemini was mostly using Gemini 3 Pro. But some variations there, yeah. Yes, so you can see they're exactly the opposite. Basically, where Claude did a really nice job, where Gemini did a really nice job, Claude did a really poor job comparative to other versions. And the null version, which is no context file at all, it was the opposite again. When I compare what I did with Gemini and then what I did with Claude. And they are opposites. If we see one agent here, this one is opposite of this one. So basically, actually doing /init for Gemini was really good. And not providing any context file for Gemini was really bad. And the exact opposite for Claude. Yes?
Sorry, I'm trying to understand what the metrics mean. So prompt tokens make sense, and then what does the score, prompt score average, what does it mean?
The score, it was, I'm sorry if I went too quickly. I asked, I gave a score basically from 0 to 10 on the completeness of the task. If the task was well implemented or not. Yes, by the same parameter. So you can see here, this one had a 9 score, 7, 9, 7, 5, 6, and so on.
Maybe last question. Since this is a very deterministic solution, why you are scoring based on 0 to 10? Is it just the complexity is solving this task?
What would you have done? What would you have done? Because I need to. Ah, okay. Oh, done or not? Okay.
Because what is the difference between 7 or 8?
Because it was. I could have showed you. Actually, he came up with a scoring system, basically saying because there were like 5 tasks that he needed to do. And for each one, he went in and see on the code base if it was implemented or not. But yeah, or maybe to 0 to 5, maybe even. Yeah. Okay. Yes?
But to do the scoring, was using the original PR
Yes.
as a control?
Yes.
Close was correct.
Yes. I had to have like a source of truth, you know. And I think it's good enough because you went through human code review and everything, and it was already on the project. I mean, of course, it could be improved, but I had to have one source of truth. Yes? I'm sorry?
If you look at Claude and without, not
this one? Yeah, okay.
Claude without any Claude and me. Yes?
Ah, is this one?
Yeah. And 100,000 is probably worse than 87.
Ah, okay. It's a number of tokens. is 108,000. So is we're trying to have the lowest number possible.
Yeah, but it's higher than 87.
One above.
No, oh yes, sorry. Oh yes, thank you. Yes, the color coding, it is, I am comparing, I'm looking at the row at a time. So I'm comparing these ones. Sorry, yes, it was not clear. Since I'm comparing the context files. So yes, so this was the lowest token consumption for this row. Okay, yeah, okay, sorry. Yeah, it's very complicated. Thank you for pointing out, because yes, that's basically a lot of numbers, and I think I didn't explain it very well. Yes, so okay, this was for having the version with the init and the version where I didn't have a context file at all. So different opposite results right there. And we can compare the blue and green versions, which were related to, this one was the comprehensive Google one, and this one was the small Google one. And interestingly, the large one, which is very, very large, remember it had 30,000 characters, it did better than the small one, than the very small one overall. And on Claude, it did bad. Basically, both of them did bad.
Sorry?
Yes.
Does it mean so far that more or less Gemini needs as much as possible of the information and Claude as
Maybe.
less as possible?
I mean, we could spend like 3 hours analyzing this and seeing it. So okay, so we can get this. I was like, oh my God, what I'm going to talk about, because there are so many information that we can get from this. I'm giving you a summary of conclusions that we may get, but we could spend hours analyzing this data. But maybe, you're right, maybe for some reason Gemini works better with more data in relation with this one. These ones were from the director of Sphere, and this one was mine. Basically, they did really bad for Gemini and really good for Claude, basically. This is what you can see. Overall red here, overall blue here. So some of the conclusions is that the init version and the no context file version, they had double flipped results. Again, the init version was really good with Gemini, bad with Claude, and the no version was good at Claude and bad with Gemini. Really interesting. The Flutter team, so the Google team comprehensive rules, so the really big file, overall they were better than the small ones from the same team on Gemini, but both were bad on Claude. And the ones from a company, they were both bad on Gemini and good on Claude. I have one hypothesis for this one, is that those ones, they were not, I mean, they were, well, mine was really big. It was almost 40,000 characters, so it was really, really big. And the one from my director, it was from another project, and it had really specific, well, it had some specific information about his project only, and his project is kind of niche, you know. And I learned that Claude actually can ignore context files if it thinks that it's not relevant to the task. So maybe this is what happened. Yes, again, I could spend hours and hours seeing. I can look the same context file and see how the results vary, or I can look at one row and see the different things and do cross things and see actually the number of lines or number of characters of the context files and so on. But as far as I am aware, this experiment was never done with Flutter or either Gemini. As I was saying in the introduction, I think a lot of people are getting more interested in really assessing and evaluating how those context files actually impact our projects. But a lot of those studies, they are made in Python, and not a lot of people are using Gemini. And I think we should have more data, even though I did 120 runs to perform the same task. I think we could analyze more data. And I called these first conclusions, but we should definitely confirm that with more data. Yes?
So what were the agents used in this case? Like, was it a anti-gravity Gemini plugin, or was it Cloud Echo or GitHub Copilot? Because LLM makes more sense in terms of token usage. But agents are also written in a way that they utilize this context file very effectively.
I didn't get,
Agents.
yes?
The coding agents, which coding agents were used?
Gemini CLI and Cloud Code.
Okay.
Yes.
Or Winston.
Yes.
Have you considered splitting it into skills? Let's say you take the most comprehensive.
I could. For this, I wanted to keep it simple. I regret it. Sometimes I say, okay, maybe I should see it not with another view, but yes, I wanted to stick only to context files. But I could put skills in the name.
Industry moves towards very short LMDs and moving everything to skills as much as possible.
Mm-hmm. Yeah. Yes. Yeah, there's so many ideas, yes.
So I'm a developer that uses lots of different kind of cutting edge technologies. So I require to switch context very frequently.
Okay.
What worked for me often is to use some kind of context management system like Context 7, for example.
Mm-hmm.
Because that way you delegate the context to a specific tool that then calls it when needed.
Yes.
And getting the information when needed. And
Okay.
keeping the Cloud MD or whatever it is
Yeah.
very lean and
Yes.
lightweight. That has worked for me consistently. Maybe it would have been cool to see it as a difference between those.
And using like Context 7, for example, or?
Yes.
Oh, okay, okay. Hey, I noted. Cool. Yes, thank you for sharing. Yes, for maybe further. But what is really cool, I think, is that I don't have a PhD. I only have, well, I mean, I'm a software developer, as much of you here. I think any person here can do the exactly same thing. Trying in a project, you already did it, giving your ideas of something. So thank you so much for giving ideas to improve or maybe have some kind of other analysis. If you have any other ideas, don't hesitate, come and see me. I'm open to everything. But we definitely can go deeper because, again, I said, I made a choice. You know, when you do stuff like this, you have to say, okay, this is what I'm going to go with. I'm picking Flutter, I'm picking Gemini and Claude. I'm only using context files and nothing more at all. I'm using the automatic model choosing by the tools, which is maybe a bad choice. I should maybe have chosen one. But we can go much deeper, as you're saying. We're saying with the skills. The ecosystem surrounding agents, context engineering, and prompt engineering, it's so large. And I mean, the context files are maybe one of the very first things that we learn when we're just trying out AI agents. But yes, we can go much further and study a lot more tools. But yes, this was my choice basically to only do the Gemini MD or Cloud MD file. And I think already there's some interesting results, but definitely maybe pick some popular skill or some hooks or everything or any other tool to see how they impact the output of our AI agents. not only there are tools, no, I talk about tools, about context files, about hooks, about things. There are actually so many people interested in thinking about infrastructures or frameworks or things, how we actually go deeper, and how do we tackle and how we can really control the better we can the context to have better results. So I definitely invite you to read more into it. I'll be sharing those slides afterwards. So really, really interesting stuff in order to better use context, especially in big, complex projects and with a lot of collaboration and so on. So that's it. Thank you so much. First of all, and again, if you have any kind of critique, any kind of ideas, or if you just want to keep in touch, see what I'm doing, because I do a lot of talks either about AI, about software engineering in general, please connect with me. And as they were saying, we must put the slide here to remind you that June 9 and 10 in Frankfurt, there's the Google Cloud Summit for the DACH region, so don't hesitate to register. Thank you again. Oh, sorry, did you? Doesn't work? Okay. Yes.
Yeah, thank you very much for your talk and your research. It was really awesome. I think you automated everything.
Yes.
Just in whole code CLI, when you work on the project, you just save in the memory automatically in the home directory of the project, and just kind of the memories about what to do and how to do. And I guess like Germany as well. And I'm just
Similar.
wondering how does it affect to in the next generation result to get the right answer and whatever. And I believe like it could affect the next generation result.
It could. You know, again, for this experiment, I one-shot it, basically. It was only one prompt. But yes, the effect of the internal memory, you're saying?
Yeah.
Yes. I think it works at the same time. Maybe another study could be done to see that in detail. I didn't. But yeah, I could. Definitely could. Yeah? Any other question? Or if you want to talk, I see. Yes, I see you.
I did some experiment with
Oh, really?
different results here.
Okay, interesting. Yes, please share. Come and see me. Yes. So yeah, thank you again. Don't hesitate and come talk to me.
All right.